Hey everyone, this is the third question of Codeforces round 521, and in this video I will be explaining the solution of it. So in the question you will be given an array and you have to print index of all the elements which you can delete exactly once and make the whole array good. Now let's first understand what does it mean by a good array. So suppose we have an array this. Now for this array to be good, there should exist an element ai such that ai equal to sum of rest of the element. Here sum denotes the sum of all the element in the array, and when I remove this ai element from this sum, this denotes the sum of rest of the element. So this makes our array an good array. Now uh, let me take you through an example. Uh, so this array contains element 8352. Now suppose in the first case I delete the first element and in the second case I delete the fourth element. So the array we have now is 352 and here we have 835. Now you can see for this array phi equal to 3 plus 2. So the new array that we got after deleting the first element became a good array. So this first index is one of our answer, and now after deleting the fourth element, the array we have now is also good because 8 equal to 3 plus 5. So overall, so for this particular question, our answer will be 2, 1, 4. 2 denotes the number of options we have, and 1 comma 4 denotes the index of the element which we can delete exactly one time and get a good array. One important thing to notice in this question is that even if the initial array given to you is already good, you still have to delete exactly one element from the array and make it good. Like in this example, we have element 10 at 10, 8 and 2. Now you can see 10 equal to 8 plus 2, so the initial array given to us is already good. But you still have to delete one element from this array and make it good. But for this particular question, there isn't any valid answer as we can't delete any one element from this array and make it good. So the answer will be 0. Now let's take another similar example like 8 comma 4 comma 4. You can again see this initial array given to us is already good as 8 equal to 4 plus 4. But for this question, we have an option to delete. Like if we delete the first element from this array, we will have 4 comma 4, and the new array that we get is again a good array as 4 equal to 4. So even after the initial array given to us is good, we can still delete the first index from this array and get a good array. So for this question, we will print 1 1. 1 means the number of options we have, so options, and this one denotes the index that we can delete and get a good array. I had already written this equation before and told you that for an array to be considered good, there should exist an element ai such that ai follows this equation. Ai should be equal to sum of the rest of the element. Now in this section I will be proving the ai that we choose has to be the max element from the array, and I will prove this result by method of contradiction. So suppose I choose an element ai which is any one of the element from the array except for the max element. So for the array to be a good array, this equation should be fulfilled. Now I can write this equation as ai equal to sum of element from first index to I minus 1, and then sum of element from I plus 1 to nth element. I have removed the element ai because this is the sum of the array except for the ai element. Now in between this element there will exist an element which is maxi, and since we are adding some positive element to this maxi, the overall sum in the right hand side will be greater than maxi. So I have written down here ai is greater than or equal to maxi. Now from the initial equation where we have chosen ai not equal to maxi, we can see that since maxi is the max element of our array, ai has to be an element which is less than maxi. So by method of contradiction, we can see that the AI that we choose has to be the max element from the array. For considering an array to be good, there should exist an element AI for which this equation holds. But later I have proved that this AI element can only be the max element of the array, for which this array can be proved good. So instead of iterating through each element of the array and checking this equation, we can just simply take the max element of the array and check if this equation holds or not. So the equation become max1 equal to sum minus max1. And now I am saying that if this equation holds for the max element of the array, then we can simply conclude that our array is a good array. But if this equation doesn't hold, this means for any other element of the array, this equation will not hold as well. So we can simply conclude that our array is not good. For solving this question, we need to calculate these four quantities from the given array. First is the sum of all the elements, then the first maximum element of the array and its index, and the second maximum element of the array. We will later see why do we need all this quantity. Now I will be solving this question in three different cases. First case says that the initial array given to us is already good. This means the max element of the array is equal to sum of the rest of the element. The second case says the max element of the array is greater than the sum of the rest of the element. And the third case is the max one element is less than the sum of the rest of the element. And later you will see that this case 1 and case 2 follow similar procedure to get to the solution. Now let's see the first case where the array given to us is already good. Uh, even if our Now let's solve the first case where the array given to us is already good. Even if the array given to us is already good, we still need to delete one element from the original array, because in the question it is already mentioned that we necessarily need to delete one element from the array and then make it good. So now we have to delete one element AI from our array. Now I am subdividing this case into two more sub cases, where in the first case the element which we delete is the max one element of our array, and then in the second case we delete an element which is not the max one element. Now let's solve this first sub case. As you may think, after deleting the max one element from our array, the sum of the rest of the element will be sum minus max one. Now we have to check for the max two element if this equation holds or not, where we have to check if the max two element is equal to sum of the rest of the element of our new array, which is this right hand quantity. And if this equation holds, we can say that the new equation that we got is a good array, and we have to simply print the index of the max one element, and that will be our answer. See the second subcase where we decide to delete an element which is not the max one of our array. So the original equation we had before deleting that AI element was this. Now we decide to delete an element AI which is not the max one of our array. So max one is still present in our array, but the sum of all the element of our new array has become this. I deleted that AI element from the whole sum. Now since the max one element is still present in our array, we have to check this equation, max one equal to sum minus AI minus max one. And if this equation holds, we can say that after deleting the element AI, the new array that we have is a good array. So if you resolve this equation, you will get this. I have named this equation 2. And if you solve this first and second equation, you will get AI equal to 0. This means if we decide to delete an element AI which is not the max one of our array, we can get a new array which can be good only if there is some AI element present in our array which is 0. But in the question it is already mentioned that all AI element is strictly greater than or equal to 1. So in the case if we decide to delete an element which is not the max one, we are never gonna get to a solution because there's no AI equal to 0 element present in our array. So the solution possible only when we decide to delete an element which is the max one of our array. Let's see the second case where max 1 is greater than sum of the rest of the element. Here you have just one choice, which is to delete this max 1 element and check for the max 2 element. So after deleting the max 1 element, the complete sum of the new array will be sum minus max 1. And now check for this max 2 element if this equation holds or not. If this equation holds, then the new array after deleting the max 1 element is good, and you just have to simply print the index of max 1 element, and this will be our answer. So this is what I was telling you earlier. Case 1 and case 2 get resolved to a similar solution, and this is what I have shown you mathematically here. Now let's see the last case where max 1 is less than sum of the rest of the element. To get equality in this equation, we have to add some delta component in the left hand side, and if we will reshuffle its term, you will get this equation. And here you can see we are actually deleting some delta value from this sum, which is equivalent to deleting some element from our original array. And what kind of element do we want to delete from our original array? We can get this by this equation. I have get this by taking this delta value in the left hand side and all other terms in the right hand side. So what I am saying is that if there exists any element ai in our array which is equal to delta, then you can simply delete that element and get a new array which is a good array. So in the final answer, you have to print index of all the element ai such that ai equal to delta, and this will be our final answer.